Inside this corroded chunk of bronze, encrusted with barnacles since 1901, are gears that shouldn't exist for another 1,000 years. It's impossible, but it's real. My name is Dr. Sarah Mitchell. I've spent the last 15 years working as an artifacts researcher at the National Museum, and the past 3 years have been consumed by one obsession, a phenomenon no one can adequately explain. Because hidden inside that corroded green lump of metal is what experts call the world's first computer, and it was built 2,100 years ago. What I'm about to show you will fundamentally change everything you thought you knew about ancient technology. Let me show you how deep this mystery goes. It was July 1901. A team of sponge divers from the Greek island of Symi, led by Captain Dimitrios Kontos, were working in the crystal blue waters between Crete and the Peloponnese. They were diving down 147 feet in search of sea sponges to supply Mediterranean markets. The work was incredibly dangerous. Divers routinely died in their 20s from decompression sickness. But on this particular day, everything changed. One of the divers, exploring the rocky seabed near the small island of Antikythera, saw something that shouldn't have been there. Bronze arms, broken statues, amphorae scattered across the ocean floor. He was looking at the remains of an ancient shipwreck, a Greek merchant vessel that sank more than 2,000 years ago carrying priceless treasures. The discovery was immediate and sensational. The Greek government launched salvage operations. For months, divers pulled marble statues, jewelry, coins, decorated vases, and dozens of bronze objects completely corroded by salt and time from the depths. Everything was taken to the National Archaeological Museum in Athens, where archaeologists began cataloging the underwater treasure. It was a monumental historical find. But what nobody noticed at first was that among those chunks of bronze covered in barnacles and marine encrustation, there was something that should not exist. Something that challenged the entire timeline of human technological history. It was 1902. The Greek archaeologist Spiridon Stias was examining artifacts recovered at the National Archaeological Museum in Athens. He picked up one of the most corroded pieces of bronze, roughly the size of a shoebox, 34 centimeters long, 18 wide, 9 high, about 13, 4x7, 1x3, 5 inches. The surface was so encrusted it looked like a rock. But when Stays looked closer, he noticed something strange. There was something inside, something mechanical. He saw the outline of a toothed wheel. Gears. Inside this ancient block of bronze were actual gears. He reported it immediately, but his colleagues weren't buying it. Their reaction was entirely predictable. Gears? In a 2,000-year-old artifact? No way. The ancient Greeks simply didn't have that technology. It had to be a mistake, maybe some modern object that somehow contaminated the wreck thousands of years after it sank. But Spiridon Stays was sure. He kept examining the artifact. The more he looked, the more gears appeared. Not just one. Several. And they were connected in an intricate, complex way that suggested a sophisticated mechanical purpose. He was looking at something that seemed designed, built, precisely made. And here's the question that's haunted me since I began studying this case. If the ancient Greeks didn't have gear technology, where did this artifact come from? And what, exactly, did it do? The answer took decades to emerge. And when it finally did, it forced historians to completely rewrite what we thought we knew about what the ancients could achieve. For years, the artifact sat forgotten in the museum's archives. But in the mid-20th century, scientists began using X-rays to examine the interiors of the bronze fragments. What they saw left everyone speechless. Inside those corroded bits of metal, there weren't just a few loose gears. There was an entire system of interconnected gears. 69 gears in total, of different sizes, arranged to move together in perfect synchronization. The largest gear was about 1 inches in diameter and had 223 teeth. And here's the crazy part. Each tooth was spaced with absolute perfection, roughly 1 millimeter apart. That means whoever built this had to hand-cut each individual tooth with millimeter precision accuracy using nothing but bronze tools, more than 2,000 years ago. That's genuinely a manufacturing achievement we'd struggle to replicate without our modern machinery. And the gears weren't mounted randomly. They were organized in specific mathematical ratios. The 223-tooth gear meshed with a 127-tooth gear. That one, in turn, connected to gears of 58 and 38 teeth. Each ratio had been calculated with astronomical precision. And when scientists began to understand the numbers, they realized something absolutely terrifying. This wasn't just a decorative mechanism. This was a computer, an analog computer, built 2,100 years ago, designed to perform calculations that would normally require years of advanced mathematics. And it did all of it mechanically, by turning bronze gears. But what exactly did it compute? The first clues came from the inscriptions. Etched into the bronze surface, almost invisible from corrosion, there was text in ancient Greek. Words related to the sun, the moon, the planets, astronomical terms. Scientists realized the mechanism wasn't just a mechanical curiosity. It had a specific purpose: to predict the motions of celestial bodies. This was an astronomical calculator, and it did so with a precision that wouldn't be seen again until the development of medieval astronomical clocks, more than 1,000 years later. The gears were set up to track the position of the sun and the moon in the sky. You turned a crank on the side of the device, and the dials on the front showed where the sun and moon would be on any future date. But it didn't stop there. The mechanism also tracked the 5 planets known in antiquity: Mercury, Venus, Mars, Jupiter, and Saturn. It modeled their movements across the sky, even accounting for the irregular orbits that make planets appear to move backward at times, a phenomenon called retrograde motion. But here's what really blows your mind. This machine didn't just track where planets were, it could actually predict eclipses, solar eclipses, lunar eclipses, decades into the future. All thanks to something called the Saros cycle, an astronomical pattern that repeats every 223 lunar months, roughly 18 years and 11 days. The ancient Greeks had figured this out through centuries of careful sky watching and observation. They'd noticed eclipses came in a predictable sequence. And someone, more than 2,000 years ago, took that knowledge and engineered it into bronze and gears. They built a machine that could predict the future of the heavens. Think about what that means. When most people saw an eclipse, they thought the gods were sending them a sign either disaster was coming or the gods approved. And then someone built a machine that turned that mystery into pure mathematics, turned fear into knowledge. And they did this 2,000 years before electricity, 2,000 years before computers. But there's more. The mechanism also tracked the Olympic cycle. The ancient Olympic Games were held every 4 years, and the mechanism had a dial dedicated to counting that cycle. That suggests whoever used it was deeply embedded in Greek culture, using it not just for astronomy, but to organize social and religious life. And here's the question that haunts archaeologists and historians. If the ancient Greeks could build something this sophisticated around 150 BC, why don't we find similar devices? Why isn't there a clear progression starting with basic mechanisms and building up to the Antikythera mechanism? Where are the practice runs? The earlier prototypes? They simply don't exist. As far as we know, this mechanism appeared out of nowhere, fully formed, and then vanished from history without leaving descendants. There is nothing remotely comparable to it in the entire ancient world. Nothing. And nothing like it would appear again until medieval astronomical clocks showed up in Europe over 1,000 years later. 1,000 years. That's what separates the Antikythera mechanism from the next similar device in recorded history. 1,000 years of technological silence. How is that possible? How could a civilization build something so advanced and then completely lose that knowledge? And if they could create this, what else were they capable of that we'll never know about because it didn't survive? The truth is, the Antikythera mechanism reveals something uncomfortable about how we understand history. We assume technological progress is always moving forward, that societies start out basic and gradually become more sophisticated. But this proves that wrong. Progress doesn't work in a straight line. It can jump forward. It can slide backward. And knowledge can disappear as fast as it was created. When you look at the Antikythera mechanism today, preserved in 82 fragments at the National Archaeological Museum in Athens, you're not just looking at an old piece of bronze. You're looking at proof that our ancestors were far more capable than we ever gave them credit for. And you're looking at a reminder that what we know about history is incomplete, fragmented, based only on what survived. So, here's what I'm going to show in the next few minutes. I will reveal exactly how this mechanism worked. I'll explain the specific technology the ancient Greeks mastered that shouldn't have existed for another 1,000 years. And I'll show what that reveals about what really happened to human knowledge across the centuries. Because this isn't just the story of an impossible artifact. This is the story of how humanity reached genius, lost it all, and had to rebuild from scratch. But that's just the beginning. When scientists finally understood what this machine could do, it shattered every assumption about ancient technology. Because hidden inside those gears was a secret that would change everything we thought we knew about what the ancient Greeks were capable of achieving. How did the ancient Greeks build a computer 2,000 years before computers existed? Stay with me, you need to see this. Scientists spent decades trying to understand what they'd found. Because when Spyridon Steas recognized those gears in 1902, he realized something disturbing. This wasn't just an ancient artifact. It was a machine with bronze gears that required mathematical precision, a machine that shouldn't have existed for another 1,000 years. But understanding what that machine did? That would take nearly a century. Let me show you what researchers discovered when they finally managed to see past the corrosion. Because what was hidden inside those fragments of bronze would rewrite everything we thought we knew about ancient technology. The first clues came from X-rays. When scientists were able to see through the corroded surface, they found something astonishing. It wasn't just a few gears. There were 69 distinct gears, 69 separate mechanical components, all working together inside a case the size of a shoebox. Think about that for a second. 69 gears in a machine built 200 years before Christ was born. But what really shocked researchers was the precision. The biggest gear had 223 teeth. 223 separate teeth cut into a bronze wheel that's only 1 inches across. Each individual tooth was about 1 millimeter long. 1 millimeter. That's smaller than the thickness of a dime. And here's the thing. To cut gear teeth with 1 millimeter precision, you need specialized tools. You need serious mathematics to calculate the spacing. You need manufacturing techniques historians thought were impossible in the ancient world. And the ancient Greeks were doing this 2,000 years ago. But there was still a huge question. What exactly did this machine do? The answer began to emerge when researchers started mapping how the gears connected. They discovered something fascinating. The ratios of the teeth on the gears weren't random. They were precise astronomical calculations. Here's what that means. Different gears had different numbers of teeth. One had 127 teeth. Another had 58. Another had 38. And when you calculate the ratios between those gears, they match the astronomical cycles known to the ancient Greeks. The Antikythera mechanism was an astronomical calculator. Basically, a machine designed to track where the sun, moon, and planets were going to be in the sky. Think about the brilliance of that. The ancient Greeks understood that the sun, moon, and planets moved in predictable patterns. They'd been watching the sky for centuries and had the math to figure out where these celestial bodies would be on any future date. But doing those calculations by hand? That was brutal. It took hours, sometimes days. You needed trained mathematicians with specialized knowledge. This mechanism did all that automatically. You just rotated an input dial to a specific date, and the machine would instantly tell you exactly where the sun, moon, and planets would appear in the sky that day. 2,000 years ago, the ancient Greeks built an analog computer that could predict astronomical positions, but that's just the beginning. Because as researchers kept studying the mechanism, they found something even more extraordinary. The machine could predict eclipses. Here's why that's unsettling. Solar and lunar eclipses follow a specific pattern called the Saros cycle. This cycle is 223 lunar months long, roughly 18 years and 11 days. After that period, eclipses repeat in the exact same sequence. The ancient Greeks had discovered the Saros cycle, but predicting when eclipses would actually happen decades in the future, that required complicated math. You had to track not just where the moon was, but also how the tilt of its orbit shifts over time. This mechanism did all of it automatically. There was a specific dial on the machine marked with 223 divisions, one for each month in the Saros cycle. You could turn that dial to any point in the future, and the machine would tell you whether there would be a solar or lunar eclipse, and exactly when it would happen. Think about what that means. Imagine you're a political or religious leader in ancient Greece. People saw eclipses as messages from the gods, cosmic events of major significance. Now imagine having a machine that could predict when those divine events would happen decades ahead of time. That's insane amounts of power. But the machine did something else too. It tracked the Olympic Games. The ancient Olympic Games happened every 4 years. That 4-year cycle was called an Olympiad, and the Greeks used it to mark time. This mechanism had a specific dial built in to keep track of exactly where you were in that 4-year cycle. So here's what we're looking at. This shoebox-sized bronze machine could calculate where the sun, moon, and planets would be. It could predict eclipses decades in advance. And it could track the Olympic Games calendar, all with nothing but bronze gears rotating in precisely calculated ratios. 2,000 years ago. No electricity, no computers, no modern technology at all. And that's still not the most disturbing part. Because when scientists finally figured out how this machine actually worked, they uncovered the real engineering genius hidden in those bronze fragments. It was something called epicyclic gearing. That's gears mounted on top of other gears that are already rotating. It's an engineering technique that multiplies how much computational power a mechanical system can handle. Here's why this matters. Basic gears connected to other basic gears give you simple ratios. One turn of the first gear makes the second gear turn a fixed amount. Fine for basic calculations. But planetary motion isn't simple. Planets speed up and slow down as they orbit. From Earth, they look like they move in weird, irregular patterns across the sky. You can't model that with basic gears. Epicyclic gearing changes everything. By stacking gears on top of already spinning gears, you create complex, irregular motion. You can model how planets accelerate and decelerate. You can capture the actual behavior of the cosmos using nothing but metal gears. It's brilliant engineering. And here's where it gets impossible. According to all our historical records, nobody reinvented epicyclic gearing until medieval Europe, in the 14th century AD. That's 1400 years after the Antikythera mechanism was built. 1400 years. Think about what that means. The ancient Greeks developed an engineering technique, and then it completely vanished from history for over 1,000 years. You can't find a comparable device anywhere else in the ancient world. No surviving instructions on how to build something like this. The technology just appeared, and then it disappeared. How is that even possible? Because we're not talking about some obscure tech that disappeared. We're talking about one of the most advanced engineering techniques in the pre-modern world. We're talking about a machine that needed multiple fields working together. Astronomers doing the math. Mathematicians converting that into gear ratios. Engineers designing the whole mechanical system. Craftspeople manufacturing everything to millimeter precision. This was way more than one person's project. It was an industrial-scale operation. You'd need serious resources, expert knowledge, and probably decades of development. And then it all just vanished. For over 1,000 years, nobody anywhere on Earth built anything like this. And that leads to a bigger question. If the ancient Greeks could build this, what else could they create? What other technologies did they develop that completely disappeared? How many engineering breakthroughs got lost when libraries burned down, empires collapsed, and people didn't pass knowledge to the next generation? The technology that wouldn't surface again for 1,000 years was trapped inside those bronze chunks that sponge divers hauled up from the ocean floor in 1901. And that raises a scary question. If something this advanced could exist and then completely vanish from the historical record, what else are we missing? What other ancient accomplishments got wiped out by time, lost to history, still waiting in some shipwreck we haven't found yet? Because this mechanism proves something unsettling about knowledge. It proves progress doesn't move in a straight line. It shows that societies can achieve extraordinary genius and then lose everything. It proves our understanding of history is seriously incomplete. And if our timeline of human technology is wrong, what else are we misunderstanding about what the ancients were capable of achieving? That's the question we'll answer next. Because understanding how the Antikythera mechanism disappeared from history reveals something deep about how human knowledge really works over time. Stick with me. It gets even more unsettling. When researchers finally understood the epicyclic gearing inside the Antikythera mechanism, everything changed. Because this wasn't just a complex machine. It was a machine that revealed a kind of genius that shouldn't have existed for another 1,000 years. Let me show you why that's so unsettling. Epicyclic gearing means putting gears inside other gears. Gears mounted on gears that are spinning. It's like having one carousel inside another carousel, both turning at the same time but at different speeds. And that setup multiplies computational power mechanically. When you turn a simple gear, you get a simple calculation, a one-to-one relation. But when you mount a gear on another gear that's already turning, you create a mathematical relationship inside another mathematical relationship. It's mechanical multiplication. It's like programming a calculator using only metal and motion. And that's exactly what the ancient Greeks did. That gear with 223 teeth wasn't just spinning on its own. It was driving multiple other gears, some of which were mounted on shafts that were spinning too. That allowed the mechanism to do something no other ancient technology could do. It multiplied calculations automatically. You turned a crank on the side, and the whole system processed multiple mathematical relationships simultaneously. Imagine having to calculate the moon's position 10 years from now. Manually, you'd have to consider its orbit around the Earth, the irregular orbit caused by the sun's gravity, variations in speed, and then apply all those changes for every month over 10 years. It would take days of raw calculation. The Antikythera mechanism did that in seconds. You turned the crank, the gears spun, and the answer appeared on the output dial. This is mechanical genius. This is analog computing. But here's what makes it truly disturbing. To build epicyclic gears, you can't just make gears. You have to craft them with absolute precision. Because if even one tooth is misaligned, if a single gear is out of proportion, the entire system fails. You get wrong calculations, you get wrong predictions, the machine doesn't work. And when scientists examined the Antikythera fragments under modern microscopes, they found something shocking. The gear teeth were roughly 1 millimeter long. 1 millimeter. Handmade. In bronze. 2,000 years ago. Think about what that means. You're working cast bronze, shaping each tooth individually, ensuring each one is spaced perfectly so the mathematical relationships are preserved. If you miss by half a millimeter, you ruin the whole gear. And they did that 69 times. 69 gears, each manufactured to 1 millimeter precision, each integrated into a system where mathematical relationships had to be perfect for the mechanism to work. This is not amateur work. This is not experimentation. This is industrial-level manufacturing. This is the kind of precision you'd expect from a civilization with advanced tools, specialized workshops, and craftsmen trained for generations to build mechanical devices. But the ancient Greeks didn't have machine shops. They didn't have gear factories. They didn't have centuries of clock-making tradition to draw on. At least that's what the documented history tells us. Because here's the part that keeps historians up at night. Researchers began comparing the Antikythera mechanism to other known mechanical devices in history. They made a timeline, mechanical devices across the centuries, to see where the mechanism fit, to see what other ancient machines used epicyclic gearing, and they found something impossible. There were no other machines, no precursor devices, no simpler versions, no prototypes. The Antikythera mechanism appears in ancient Greece around 150 BCE. And then, nothing. For 1,000 years. 1,000 years without epicyclic gearing. 1,000 years without mechanical computation. 1,000 years without anything remotely like it. The next time epicyclic gears show up in the recorded history is in medieval Europe, in the 14th century. 1,400 years later. Let that sink in. That technology was invented. It worked. It was so sophisticated it could predict eclipses decades in advance. And then, it simply vanished. For more than a millennium. It's like someone building a smartphone in the year 1300, and then everyone forgetting how to make phones until 2700. It's like discovering a car in the Middle Ages and then there being no cars again until the 20th century. It's a kind of technological gap that shouldn't be possible, because technological progress doesn't work like that. Technology spreads, it's copied, it's improved, it becomes more widespread, not less. You don't invent the computer, and then everyone forgets computers are possible. But that's exactly what happened here. And it's not just that the technology disappeared. It's that nothing like it existed anywhere else in the ancient world. Researchers searched everywhere. Chinese civilizations, Roman technology, Middle East, India, Egypt. They looked for any evidence of mechanical gearing anywhere from that period. Nothing. Zero. Zilch. This mechanism isn't just advanced for its time. It's completely isolated. It's an abandoned artifact, a technological accomplishment with no predecessors, no successors, no equivalent anywhere in the ancient world. That shouldn't happen. Inventions don't just materialize. They develop slowly. Prototypes, simpler versions, experimental tries. You don't jump straight from zero to a 69-gear machine that tracks planets. Yet that's exactly what the ancient Greeks seem to have done. Or at least that's what the evidence shows. Because if earlier prototypes existed, if simpler versions were around, if whole shops were making this tech, they all disappeared. Lost to history. Lost to time. Lost so completely that we only know about this mechanism because it sat on the ocean floor for 2,000 years. And that's the question historians can't answer. If something this advanced could exist and then completely vanish, what are we missing? What other ancient technological breakthroughs disappeared, leaving zero trace? How many discoveries got forgotten, burned, destroyed, or just never written down? Here's the uncomfortable reality this mechanism forces us to accept. By written history, this is impossible. By everything we think we know about ancient technology, this couldn't have been built. And yet, it absolutely exists. Right now, it's sitting in the National Archaeological Museum in Athens. 82 bronze fragments, 69 gears, 2,100 years old, still works, absolutely real, should be impossible. So how did they do it? How did the ancient Greeks master this gearing technique 1,000 years before medieval Europe? How did they get millimeter precision without modern tools? How did they design something so complex that 20th century scientists actually thought it was a fake because it was way too sophisticated to be ancient? And the scariest question, if they could make this, what else could they create that history never documented? Because this mechanism proves something deeply troubling about knowledge. It shows progress doesn't move straight up. It demonstrates civilizations can reach amazing genius and then lose it completely. It proves the history we learn, the technology timeline we think is true, might be fundamentally flawed. What if we're completely wrong about ancient technology? What else are we misunderstanding? This artifact forces us to face an uncomfortable truth about history. It makes us ask, what we know about the past is that everything that actually happened, or just what happened to survive? Because this mechanism barely survived. If those sponge divers hadn't stumbled on that wreck in 1901, if Spiridon Stays hadn't spotted those gears in the corroded bronze, if scientists hadn't spent decades analyzing those fragments, we'd still be convinced the ancient Greeks had no gearing technology. We'd still think mechanical computing started in medieval Europe. We'd still have our neat timeline of history where everything smoothly evolved from simple to complex. But we know better now. We know that 2,000 years ago, someone in ancient Greece built a machine that shouldn't exist. And then, for reasons we still can't fully explain, that knowledge disappeared. And that leaves us with the scariest question. If the ancient Greeks could build this, what else could they have created? What other breakthroughs disappeared when libraries went up in flames, when empires crumbled, when people didn't hand down what they knew? What other genius is sitting on the ocean floor, undiscovered, unrecognized, waiting to flip everything we think we know about ancient humans upside down? Stick with me. Understanding how this knowledge vanished reveals something crucial about how knowledge actually works across time. And what we'll discover is even more unsettling than the machine itself. The real question isn't just, how did they build this? The question that should haunt us is, why did we forget they could? Here's the disturbing part. The Antikythera mechanism shows up in the historical record around 150 to 60 BCE. And then it just vanishes. No version 2. Zero. No improved models. No students making imperfect copies to learn the craft. The technology simply evaporates. And that's not how technology usually works. When we develop something revolutionary, we see a progression. Primitive tools, iterations, gradual improvements. We can trace the evolution of almost everything, from the wheel to the smartphone, through a clear line of incremental development. But the Antikythera mechanism has no such line. There are no intermediate artifacts, no simpler devices showing the ancient Greeks learning how to make gears, no failed prototypes in museums labeled early attempt at astronomical computation. It's as if someone jumped from zero straight to mechanical genius and then just stopped. And that forces us to confront an uncomfortable truth about how we understand history. We assume human knowledge progresses linearly, that each generation builds on the last, that once something is discovered, it stays discovered. But the Antikythera mechanism proves that assumption wrong. Knowledge can be lost. Sophistication can regress. Entire civilizations can forget what they once knew. And the reason we know this is because it happened with this device. Someone in ancient Greece mastered the epicyclic gear, built a precision astronomical computer with 69 bronze gears, and then, that knowledge simply wasn't passed on. It doesn't appear again in medieval Europe until 1,000 years later. 1,000 years. So what happened? Why did this technology disappear? The honest answer is, we don't know for sure. But we have some disturbing clues. First, think about how ancient knowledge actually stayed around. No internet, no printing presses. If you wanted knowledge to survive, you had to write it out by hand on parchment or papyrus. Then you had to hope someone copied it before the original fell apart. Most ancient knowledge just didn't make it. We lost roughly 90% of all ancient Greek literature. 90%. Just gone. Burned in fires. Rotted in wet storage, thrown out when wars destroyed libraries. The Library of Alexandria, with supposedly hundreds of thousands of scrolls containing all the world's knowledge, got destroyed. Exactly when and how is debated, but the result is the same. All that knowledge erased. And here's where it gets scary. We know from fragments and surviving texts that ancient Greeks actually wrote about mechanical devices. Archimedes, one of the greatest mathematicians and engineers in history, supposedly built planetary spheres that modeled how celestial bodies moved. The Roman orator Cicero wrote about seeing one of Archimedes' spheres. He described it simulating the sun, moon, and planets. But the actual devices? Gone. The instruction books on how to build them? Lost. The Antikythera mechanism might be the only remaining example of an entire category of ancient tech that just disappeared when libraries burned and empires broke. So we need to completely rethink what we thought we knew about ancient technology. For decades, even centuries, historians assumed the ancient Greeks were amazing at philosophy and math, but technologically behind later civilizations. That assumption is clearly wrong. If they could create this mechanism with its advanced epicyclic gearing and accurate astronomical models, what else could they have built that didn't make it to modern times? What other engineering breakthroughs got lost? And here's what should really make us think. The mathematical skill needed to design this device shows the ancient Greeks understood astronomical and math concepts we usually say came much later. To make those gears track the moon's weird movements, they had to understand astronomical theories we thought were invented centuries later. The same question keeps popping up. What other knowledge did they have that we don't recognize? And that brings us to something bigger about how technology actually progresses. We assume it moves straight up. Stone Age to Bronze Age to Iron Age to Industrial Revolution to Digital Age. Each stage obviously building on the last. But this mechanism proves that model is way too simple. Technological progress isn't automatic, it's not guaranteed, and it's not permanent. Societies can reach impressive sophistication, and then lose all that knowledge if the conditions for keeping it aren't there. The ancient Greeks pulled off something incredible with this device. But when their world fell apart, when libraries burned, when knowledge wasn't passed down, when what society valued changed, that whole engineering breakthrough just vanished from memory. It stayed lost until sponge divers randomly found it at the bottom of the Aegean Sea in 1901. Think about that. If that shipwreck had never been found, if those divers had searched a different spot that day, we still wouldn't believe the ancient Greeks could build computers. We'd still be working under the wrong idea that advanced gearing started in medieval Europe. We'd still be seriously underestimating what ancient technology could do. And here's the scary part. How many other ancient breakthroughs are sitting on the ocean floor, buried under modern cities, or gone forever because no one preserved them? How many other devices like this existed that just turned to dust before anyone could record them? But there's something more important happening than just grieving lost knowledge. This mechanism forces us to completely rethink how we understand human capability over time. For a while, we've been working under something called temporal superiority bias. The idea that being later in history makes us smarter, more capable, more technologically advanced than people who came before. But this artifact destroys that assumption. The ancient Greeks who built this weren't less intelligent than us. They weren't less creative. They weren't less capable of amazing technical work. They just worked in different circumstances. And when those circumstances changed, when their libraries burned and their knowledge wasn't saved, their achievement just vanished. Which is a crucial lesson for today. Because we think our technological knowledge is permanent. Because it's digital and spread globally, it can't disappear. But history says otherwise. Knowledge is fragile. Civilization is fragile. And what we assume is safe can vanish faster than we think if we don't protect and pass it down carefully. The ancient Greeks were geniuses, but their genius couldn't guarantee their knowledge would last. And that should humble all of us. And here's the coolest part. We're still learning new things about this mechanism. Even now in the 2020s, over 100 years after finding it, researchers keep discovering features and abilities we didn't know about. New studies with CT scans and high-res X-ray imaging show inscriptions and gear designs invisible to the eye. Every new scan reveals more sophistication, which means right now, with all our modern technology and analysis, we still don't completely understand what the ancient Greeks could actually do 2100 years ago. Let that sink in. With all our science, computers, and tools, we're still trying to understand what the ancient Greeks made with hand tools and watching the night sky. It's not just cool, it's genuinely humbling. And it makes us ask a question we should have asked way earlier. What else were ancient people capable of that never made it into history? What other breakthroughs are waiting to be found that will shake up everything we think we know about our ancestors? Because this mechanism proves one definite thing. Ancient humans were way more capable than traditional history suggested. And every find like this changes how we understand what humanity could always do. It wasn't that ancient people were stupider or less creative. It's that the historical record was incomplete. Records disappeared. We built stories based on broken evidence that left out huge parts of the truth. But this mechanism made it. And its surviving changes absolutely everything. It changes how we see ancient Greeks. It changes how we understand technology progressing. It changes how we think about knowledge through the ages. And more importantly, it changes how we see what humans are truly capable of. Because this proves that 2100 years ago, someone in ancient Greece had the brilliance to imagine an astronomical computer, the math skills to design it, and the technical expertise to actually build it. So if they could do that, what does that say about what humans have always been capable of when things line up right? Keep watching. Understanding the specific genius in those gears reveals something even more amazing about how those ancient minds worked. And what you'll see is human capability in a completely different way. Building this mechanism took the ancient Greeks 3 kinds of genius. And once you see how complex each one was, you realize this wasn't just luck. It was a perfect blend of astronomical knowledge, mathematical brilliance, and technical skill that needed the smartest minds of the era working together perfectly. Let me show you how absolutely remarkable this actually was. First, the astronomy. This mechanism could only work if the ancient Greeks understood the sky with crazy precision, not casual stargazing. Systematic tracking of planets, eclipse math, measurements refined over decades or centuries. They knew the moon's cycle was 29. 5 days. That's the synodic month, the time between one new moon and the next. They built gears that captured that rhythm perfectly. But that was just the start. The real breakthrough was the Saros cycle. This is the eclipse pattern ancient Greek astronomers discovered through careful watching over generations. 223 lunar months. Exactly 18 years and 11 days. When that period ended, the moon, Earth, and sun were back in almost the same positions. And eclipses repeated. Think about it. Someone, 2100 years ago, was watching the sky every single night. Year after year, writing down every eclipse, every oddity, every pattern. Then they found the math hidden in what looked like chaos. No telescopes, no computers, just eyes, records, and brains. Here's the amazing part. They didn't stop at discovering the Saros cycle. They made a 223-tooth gear about 1 inch wide to represent it mechanically. This one gear let the mechanism predict solar and lunar eclipses years ahead. You spun the crank, and the machine showed you when the sun would disappear. Think about the power that gave. When people thought eclipses were messages from the gods, you had a machine that predicted the future with pure math. Not magic. Real science. And the Greeks understood it. But just understanding the astronomy wasn't enough. You had to turn that into math. And that's where the second kind of genius appears. The mathematical skill to figure out the gear relationships. The core problem this mechanism had to solve. Planets don't move at constant speeds. The moon speeds up and slows down because of its elliptical path and gravity. Planets look like they reverse direction in the sky. If you want to build a machine that shows this, you can't just use gears spinning at fixed speeds. You need changing motion. You need mechanical math. The Greeks solved it with epicyclic gears. Gears mounted on other gears that are already spinning. This was the revolutionary idea that made it all work. When you put a gear on the edge of another rotating gear, the result isn't just simple circular motion, it's complex, changing. And with the right tooth numbers, you can replicate irregular celestial motion with mechanical precision. Figuring out those ratios was serious math. For every gear, you had to calculate exactly how many teeth it needed for the right ratio. The 127-tooth gear, the 58-tooth gear, the 38-tooth gear. Each served a specific job in the whole computational design. One tooth off and the whole system breaks. Predictions fail. It doesn't work. So someone, 2100 years ago, did this math. Probably with Euclidean geometry, Pythagorean ideas, and math thinking that would make sense to us today. They built an analog machine that could calculate future planet positions just by turning bronze gears. They invented mechanical computing 1,000 years before medieval Europe even thought of it. Let that really sink in. The ancient Greeks weren't reaching toward modern technology. They already had it. In their own form, using what they had available, but doing the exact same thing. A computer that predicted the stars and actually worked. And now for the third kind of genius. The skill needed to actually make this machine. Getting the astronomy right and doing the math is one thing. Building the actual pieces with enough precision to work is completely different. Each tooth was about 1 millimeter. That's smaller than a grain of rice, about 0.04 inches. There were 69 gears total, maybe more that are gone now. Every single one was handmade, using bronze tools, in a time with no precision machines, no measuring devices, no modern manufacturing at all. It started with casting bronze. Melt it down, create the basic discs that become gears. But casting alone doesn't give you the precision you need. Every tooth had to be filed by hand, carved with harder metal tools, sharpened and shaped until it's perfect. Not an afternoon project. Weeks, maybe months, of work for a craftsperson who knew both metalwork and mechanical design. Then assembly. 69 gears, stacked, put on shafts, all spinning smooth with no friction, all fitting perfectly with their neighboring gears. A ½ millimeter off and the whole thing jams. An unbalanced gear and it runs rough, messing up the math. Whoever built this had technical skills that match modern watchmakers, 2,000 years before European clockmaking even existed. No past examples to copy, no gear-making tradition. Had to create it all from nothing. And that tells me something important. This mechanism wasn't built by one person. It was teamwork. Astronomers understanding the sky. Mathematicians turning sky observations into gear formulas. Engineers designing the mechanical system. Craftspeople making parts to impossible accuracy. All working together, probably for years, building something completely new. This was interdisciplinary work. Different kinds of expertise coming together in one machine. And it shows us something crucial about ancient Greek culture. They had the structure to support that teamwork. Schools teaching astronomy. Shops where craftspeople got really good. Wealthy people funding big projects with no quick payoff. A society that valued learning itself. And we know it actually worked. Modern scientists built working copies. They took what was left, rebuilt the gears, and proved the original design worked exactly right. Turn the crank, the gears calculate where planets are. Check the eclipse dial, it shows when the sun disappears. 2,000 years later, their design still works perfectly. This isn't guessing. It's not romanticizing history. It's proof that ancient people could do this. The Greeks who built this were our intellectual equals in every real way. They watched the universe, asked questions, used serious math, and built machines to find answers. They did science exactly like we do, just with different tools. And once you really get it, once you understand how massive their achievement was, something changes. You stop seeing ancient people as primitive. You stop thinking progress is just moving from dumb to smart. You realize human intelligence, creativity, and problem-solving haven't evolved in 2,000 years. It was always there, just waiting for the right setup. This mechanism proves it in a way no ancient book ever could. Books get misread. Books get mistranslated or blow things up. But this object doesn't lie. It's real. You can hold it. You can X-ray it. You can count the teeth and do the math yourself. And when you do that, you see the truth. 2,100 years ago, someone in ancient Greece had the vision to design an astronomical computer, the math skills to plan it, and the technical knowledge to actually build it. So if they could do that, what does it say about what humans are actually capable of when conditions work out right? When knowledge moves freely, when people from different fields work together, when society cares about discovery, not just profit, when craftspeople and thinkers are both respected, when money funds big long-term projects. The ancient Greeks set up those conditions. The result was a device so advanced it disappeared from history for 1,000 years because people couldn't believe it actually existed. But here's the bigger truth this mechanism shows. It's not just looking back at what they did. It's asking, what are we missing right now? What brilliance is stuck because people don't have resources, teamwork, or recognition? How many modern breakthrough ideas are being thought of right now by smart people who'll never get to build them? The lesson isn't that ancient people were surprisingly intelligent. It's that people have always been surprisingly intelligent. And when we build the right conditions to support intelligence, different fields working together, intellectual freedom, respect for craftspeople, money for pure learning, we do impossible things. The Greeks pulled it off 2,100 years ago. Then things changed. Knowledge disappeared. Skills were lost. And humans needed 1,000 years to reinvent something already built. If they could make this from bronze and math, what could we build now? And more importantly, what aren't we building because we're not creating conditions for brilliance? This mechanism does more than change how we see history. It changes what we believe is possible today. And that more than any gear or eclipse math is its actual power. Keep watching. What this reveals about knowledge, time, and how fragile civilization is will shake up everything you think you know about history. And what it means for how we live today will completely change your perspective. So when you see the bronze pieces in the National Archaeological Museum in Athens, you're not just seeing an old machine. You're seeing proof that human ability is almost unlimited when things line up right. You're seeing that progress isn't guaranteed, it's fragile. And you're seeing a challenge. This mechanism isn't just a thing. It's proof we've been telling the wrong story. For decades, even hundreds of years, historians wrote about what ancient people could build based on one thing: written records, texts, books, stone carvings. If nobody wrote it down, it didn't happen. But that approach has a huge problem. Written records are incomplete. They're biased. They focus on certain people, certain knowledge, certain stuff, and they miss everything else. Ask yourself, how many ancient books described machines like this? 0. How many carvings mentioned epicyclic gears or eclipse math in bronze? None. So by written records, this should never exist, but it does. 82 bronze pieces prove it. And suddenly everything we thought we knew about ancient technology is wrong. Because if ancient Greeks could build an analog computer 2,100 years ago with 0 written records, what else did they make that we lost? What other tech existed and disappeared without ever being written down? Honestly, we don't know. And that's the scariest part. This mechanism shows something seriously disturbing about how we understand history. It proves ancient civilizations were way more advanced than we thought. Not because evidence was missing, but because we weren't looking in the right spots. Not because ancient people couldn't do it, but because our history methods had huge gaps. And that leads to something even bigger: how fragile knowledge really is. This mechanism didn't just happen by accident. It was built by people with incredible knowledge of astronomy, math, and engineering. People who knew geometry, understood sky cycles, were experts in bronze precision work. That knowledge wasn't instant. It took generations. And then it just vanished. Completely gone. For over 1,000 years, medieval Europeans had no clue epicyclic gears were even possible. Nobody knew ancient Greeks could predict eclipses with machines. That entire knowledge base just disappeared. And here's the question that should scare us. How does that even happen? How does a civilization reach that level of genius and then lose everything? The answer is how fragile knowledge really is. Knowledge isn't floating in the air. It has to be taught, master to student, generation to generation. Break that chain, the experts die without teaching anyone, and the knowledge is gone. It's exactly what happened with the Library of Alexandria. Thousands of old books, centuries of learning, lost forever when the library burned. Not bad books, just no copies, no backup. Fire consumed the scrolls and centuries of knowledge turned to ash. This mechanism is a physical lesson in how quick genius can vanish. It's a warning. Progress isn't a straight climb, it's fragile and can reverse. And this changes everything about how we should live today. If ancient Greeks could lose advanced knowledge, what are we losing right now? What abilities are disappearing because we're not teaching younger people? What could we build if we had the right setup? Think about it. Traditional skills vanish every single day. Crafts refined over centuries get abandoned because nobody learns them. Indigenous languages die when the last speakers pass. Knowledge about nature built up for generations disappears because society doesn't value it. We're repeating the same error old civilizations made. Assuming knowledge is always there, progress is automatic. What we know can't go away. This mechanism proves that's wrong. There's one more question. How many ancient civilizations built incredible tech that just didn't last? This mechanism survived totally by accident. A shipwreck, protected on the seafloor for 2,000 years, found by divers not looking for it. If that ship hadn't sunk right there, if divers hadn't gone down at exactly that spot, it's gone forever. How many other machines got melted down? How many were destroyed in wars, stolen, worn away with nothing left? The Antikythera mechanism was probably not one of a kind. Likely other similar devices existed, maybe better ones, but they all disappeared. If this one example hadn't survived by pure luck, we'd never believe ancient Greeks could build computers. So, our understanding of history is way less complete than we realize. If we're this wrong about ancient Greek tech, how wrong are we about other civilizations? The Egyptians, the Maya, ancient China. What other amazing tech existed and got erased? Answer: we don't know. Never will completely. But here's what we do know. Ancient people were way more intelligent and capable than history books say. Not primitive, not limited. Not waiting for modern science to think big. They were geniuses, using their tools, solving hard sky problems with bronze and math, building tech that wouldn't be matched for more than 1,000 years. And if they did it 2,100 years ago, what does that mean for human potential overall? It means genius isn't something new. It didn't start with the Industrial Revolution or computers. Genius has always been here. Every time period, every culture, just waiting for the right setup. What changed isn't what people can do. What changes is circumstance. Having resources, stable government, caring about learning, people working across different skills. When those things line up, amazing things happen. When they don't line up, talent gets wasted. Knowledge vanishes. Progress stops. So when you look at the bronze in the National Archaeological Museum in Athens right now, ask yourself, what made this device possible? What conditions let it disappear? But more important, are we set up for genius today? Do we respect learning? Are we funding education, science, teamwork across fields? Are we protecting knowledge for the future? Or are we headed toward another time of loss? When advanced tech vanishes because nobody values it, nobody protects it, nobody teaches it. Because the lesson of the Antikythera mechanism isn't just history, it's right now. It's about the future. It's about knowing progress isn't automatic. Knowledge is fragile. Genius needs the right conditions. It's about understanding people, anytime, anywhere, can do incredible things when the situation allows. In 1901, sponge divers pulled this from the ocean. And they showed that 2,100 years ago people were capable of brilliance we're struggling to understand now. They proved ancient Greeks weren't waiting for us to teach them how to think deeply. They were already there, calculating how planets move, predicting eclipses, building machines that shouldn't exist for another 1,000 years. And that transforms everything. Changes how we see the past. Changes what we understand about human ability. Changes what we think is possible. Because if they could build this with bronze and math, there's no cap on what people can do when conditions work. This mechanism shows our ancestors were incredible. Human intelligence isn't something modern. It's always been human. And dismissing the past means dismissing what we're capable of right now. Next time someone says something's impossible, remember this. 2,100 years ago, ancient Greeks built a computer with 69 bronze gears, a device that predicted eclipses, tracked planets, modeled the sky with precise math. And people didn't believe it was real until they held it. History shows impossible things becoming real all the time. This mechanism is just one, but maybe the most powerful, because it's not theory, it's not guessing, it's a real object. 82 bronze pieces you can touch, examine, study. It's clear proof we got the past wrong. If we got the past wrong, maybe we're wrong about a lot more things. Maybe we're underestimating what ancient people could build. Maybe we're missing wisdom we don't even recognize. Maybe we're throwing away knowledge that future people will regret we didn't save. Or maybe we're underestimating what we can build right now if we stopped thinking we know everything. This mechanism is in Athens today. 82 bronze pieces showing our ancestors were geniuses. If they did it 2,100 years ago, imagine what we could build right now that we haven't thought of yet. Because the biggest lesson from this mechanism isn't technology. It's not gears, or Skyfax, or machines. It's being humble. About realizing we don't have all the answers. History is more complicated than textbooks show. Brilliance has always been here, every time period, waiting to be uncovered. And it's respecting the ancients, not as backward people needing our help, but as our equals, as brilliant people who solved impossible problems with what they had. Because looking at this mechanism isn't the past. It's a mirror. It shows what humans have always been able to do. A warning about what disappears if we're careless. So question what you think you know about history. Facts don't lie. And this is the clearest example of all. 2,100 years ago, someone built a machine that shouldn't exist, and it forever changed what we think is possible. If this shifted how you see history, share it. More people knowing about this mechanism means more people honoring the ancient minds behind it. It means remembering brilliance has no time, no place. It just needs the right setup to happen. And maybe by seeing genius in the past, we build conditions for genius in the future.